What if reality isn't solid at all, but a shimmering illusion of probabilities? Imagine a world where particles vanish and reappear, where cats live and die at the same time, and where the universe itself rewrites its laws the moment you look at it. Welcome to quantum mechanics, the hidden code of creation, the divine dice roll of existence, the frontier where science meets the impossible. What if the world around you is not as solid as it seems? What if the chair you sit on, the air you breathe, and even your own body are built from something far stranger than you can imagine? This is where our journey begins, inside the hidden world of quantum mechanics. Quantum mechanics is the science of the very small. It looks at particles so tiny that you cannot see them, even with the most powerful microscope. These particles are the building blocks of everything. Atoms, electrons, photons of light. But here's the shocking part, they do not behave like the solid objects we know in everyday life. Instead, they act in ways that seem impossible. Imagine throwing a ball. You expect it to fly through the air in one clear path. But in the quantum world, a particle can take many paths at once. It can be here, there, and everywhere, all at the same time. This strange behavior is called superposition. It means particles can exist in multiple states until we look at them. Only when we observe them do they choose a position. It's as if reality waits for us to watch before deciding what is real. This is not just theory, it has been proven again and again in experiments. Scientists fire particles through tiny slits and watch them create patterns of waves, as if the particles are ripples of water. But when someone observes them closely, the particles suddenly act like solid bullets instead. This is known as the double-slit experiment, and it is one of the most famous mysteries in science. It shows us that the act of watching changes the outcome. Reality itself bends to the observer. Think about that for a moment. The universe is not fixed. It is fluid, uncertain, and shaped by interaction. This is why quantum mechanics feels so epic. It challenges everything we thought we knew about existence. It tells us that certainty is an illusion, and probability rules the deepest layers of reality. But don't worry, this is not chaos. Quantum mechanics has rules, even if they are strange. These rules allow us to build lasers, computers, and even the smartphones in our pockets. Without quantum mechanics, modern technology would not exist. The invisible dance of particles powers the visible world. Now that we've shattered the illusion of solid reality, let's step deeper into the hidden world, the quantum realm. This is the place where the rules of everyday life break down, and particles behave in ways that seem magical. In our normal world, things are predictable. If you drop a ball, it falls. If you turn on a light, the room brightens. Cause and effect feel simple. But in the quantum world, the smallest particles, like electrons and photons, do not follow these simple rules. They live in a strange twilight zone between possibility and reality. One of the most mind-bending ideas in quantum mechanics is wave-particle duality. It means that tiny particles can act both like solid objects and like waves of energy. Imagine light, sometimes it behaves like a stream of bullets, hitting a target one by one. Other times, it spreads out like ripples on a pond, interfering with itself and creating patterns. How can it be both? That's the mystery of the quantum realm. Think of it this way, particles are not just things. They are also waves of probability. They carry information about where they might be, not just where they are. Until we measure them, they exist in a cloud of possibilities. This is why scientists say the quantum world is ruled by probability, not certainty. To make this clearer, imagine you are rolling dice. Before the dice land, there are many possible outcomes. In the quantum world, particles live in that state of possibility all the time. They are like dice that never stop rolling, until someone looks. When we observe them, the dice collapse into a single result. Reality chooses. This strange behavior is not just theory. It has been tested in countless experiments. And it is not limited to light. Electrons, atoms, even molecules can show wave-like behavior. The deeper scientists look, the more they find that everything in the universe is built on this strange duality. So, what does this mean for us? It means that the universe is not made of solid building blocks, but of shimmering waves of probability. It means that reality is flexible, uncertain, and alive with hidden possibilities. And it means that the everyday world we see is only the surface of something far more mysterious. Now we step into the strangest part of the quantum world, the paradoxes. These are the puzzles that make scientists scratch their heads and storytellers dream of impossible worlds. They show us that quantum mechanics is not just science, it is a mystery that bends the rules of logic. The most famous paradox is Schrödinger's cat. Imagine a cat inside a box. Alongside the cat is a device that can release poison if a particle behaves a certain way. In the quantum world, until we look inside, the particle exists in two states at once. That means the cat is both alive and dead at the same time. Only when we open the box does reality choose one outcome. Alive or dead. This thought experiment shows how strange superposition really is. It is not just about particles, it can be imagined on a larger scale, even with life itself. Another paradox is superposition itself. Particles can exist in multiple states at once. An electron can spin clockwise and counterclockwise at the same time. It is like flipping a coin and having it land on both heads and tails. This is not science fiction, it is real, tested, and proven. Superposition is the reason quantum computers are so powerful. They can hold many possibilities at once, solving problems faster than ordinary computers. Then there is entanglement, which Albert Einstein called spooky action at a distance. Imagine two particles that are linked together. No matter how far apart they are, across a room, across a galaxy, when one changes, the other changes instantly. It is as if they share a hidden connection faster than light. This breaks our normal idea of space and time. It suggests that the universe has deeper links we cannot see. These paradoxes are not just tricks. They are real features of the quantum world. They challenge our understanding of reality. They make us ask, is the universe fixed, or is it flexible? Are we discovering laws, or are we shaping them by observing? Now we arrive at one of the most mysterious ideas in quantum mechanics, the observer effect. This is the strange truth that simply watching something can change what happens. In the quantum world, the act of observation is not passive. It is powerful. It rewrites reality. Let's go back to the famous double-slit experiment. When particles are fired through two slits, they create a wave pattern, as if they are ripples of water spreading out. But when scientists set up detectors to watch which slit the particle goes through, the wave pattern disappears. Instead, the particles act like tiny bullets, choosing one slit or the other. Just by observing, the outcome changes. Reality collapses from possibility into certainty. Think about that. In our everyday world, watching something doesn't change it. If you watch a ball roll across the floor, it doesn't suddenly behave differently. But in the quantum world, particles seem to know when they are being observed. They shift from waves of probability into solid states. It is as if the universe waits for us to look before deciding what is real. This raises deep questions. Does reality exist without observation? Is the universe a cloud of possibilities until someone, or something, watches? Some scientists argue that observation is not about human eyes, but about interaction. When particles collide or interact with their environment, that counts as observation. Others wonder if consciousness itself plays a role. Could our awareness shape reality at the deepest level? The observer effect is not just philosophy, it is practical science. It explains why quantum systems are so delicate. In quantum computers, particles must stay in superposition to hold multiple possibilities. But the moment they are disturbed or observed, they collapse into one state, losing their quantum power. This is why building quantum technology is so challenging. The act of measuring can destroy the very effect we want to use. So far, we've explored the mysteries of the quantum world, particles that act like waves, cats that are both alive and dead, and reality that changes when we watch. But quantum mechanics is not just strange theory. It is also the foundation of modern technology. Without it, our world today would look very different. Let's start with lasers. Lasers are beams of light so precise and powerful that they can cut steel, scan barcodes, and even perform delicate eye surgery. They work because of quantum mechanics. Inside a laser, atoms are excited to higher energy levels. When they drop back down, they release photons, tiny packets of light. Quantum rules make these photons line up perfectly, creating a sharp, focused beam. Without quantum mechanics, lasers would not exist. Next, think about semiconductors. These are the materials inside every computer chip, smartphone, and modern electronic device. Semiconductors rely on quantum mechanics to control how electrons move. By designing materials at the quantum level, engineers can make switches that turn on and off billions of times per second. This is what allows computers to process information so quickly. Quantum mechanics is the invisible engine behind the digital revolution. But the most exciting frontier is quantum computing. Ordinary computers use bits, tiny switches that are either 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time, thanks to superposition. This means they can explore many possibilities at once. Imagine solving a maze. A normal computer tries one path at a time, but a quantum computer can try all paths at once. This makes it incredibly powerful for solving complex problems, like designing new medicines, cracking codes, or simulating the universe itself. Quantum technology is not just about speed. It is also about security. Quantum communication uses entanglement to send information in ways that cannot be hacked. If someone tries to intercept the message, the quantum link breaks, and the intrusion is revealed. This could lead to unbreakable encryption, protecting data in a way that has never been possible before. The quantum world is not only strange, it feels almost spiritual. Its mysteries echo the myths and legends humans have told for thousands of years. When we look at quantum mechanics, we see science, but we also glimpse something deeper, a universe that behaves like a story of divine mystery. Take superposition. Particles exist in many states at once, waiting to be observed. This reminds us of ancient myths where gods or spirits lived in multiple forms. Both visible and invisible, both present and hidden. Just as myths describe beings who are everywhere at once, quantum mechanics shows us particles that defy location, existing in a cloud of possibilities. Then there is entanglement. Two particles linked across vast distances, changing together instantly. This feels like the mythic idea of destiny or divine connection. In many traditions, souls or spirits are bound together, no matter how far apart. Quantum entanglement is the scientific version of this mystery, a hidden thread tying the universe together. The observer effect also carries a mythic echo. The idea that reality changes when it is watched feels like the stories of creation, where the universe comes into being when spoken, seen, or named. In the Bible, God says, "Let there be light," and light appears. In quantum mechanics, particles collapse into reality when observed. Science and myth both tell us, attention shapes existence. Even the randomness of quantum mechanics, the rolling dice of probability, connects to ancient ideas of fate. The Greeks spoke of the fates weaving destiny. The Bible speaks of casting lots to reveal divine will. Quantum mechanics shows us that chance is not just chaos, it is woven into the fabric of reality. The universe plays dice, and those dice create the world we live in. We've seen how quantum mechanics explains the mysteries of particles and powers today's technology. But the most exciting part is what comes next, the future frontier. Quantum science is opening doors to possibilities that sound like science fiction, yet they are already being explored in laboratories around the world. One of the biggest frontiers is quantum computing. Ordinary computers are powerful, but they are limited. They use bits that can only be 0 or 1. Quantum computers use qubits, which can be 0, 1, or both at the same time. This means they can process many possibilities at once. Imagine trying to solve a puzzle with billions of pieces. A normal computer would take years. A quantum computer could solve it in seconds. This could transform medicine, climate research, and even artificial intelligence. It is like unlocking a new level of human knowledge. Another frontier is quantum teleportation. No, this doesn't mean teleporting people like in science fiction movies. It means teleporting information. Using entanglement, scientists can transfer the state of a particle instantly across distance. This could lead to ultra-secure communication, where information travels faster than light and cannot be hacked. It feels like magic, but it is real science being tested today. Then there is the dream of limitless energy. Quantum mechanics may hold the key to new forms of power. Imagine tapping into the quantum vacuum, the energy hidden in empty space. If scientists can harness this, it could provide clean, endless energy for the world. No pollution, no limits, just pure power from the fabric of reality itself. It sounds unbelievable, but research is already exploring these possibilities. The future frontier also includes quantum sensors. These devices can measure things with incredible precision: gravity, magnetic fields, even the tiniest changes in the environment. They could revolutionize medicine, navigation, and exploration. Imagine ships guided by quantum sensors, or doctors diagnosing diseases instantly with quantum scans. We have traveled through the mysteries of the quantum world. We have seen particles act like waves, cats live and die at the same time, and reality itself bend when we watch. We have explored paradoxes, technologies, and even mythic echoes hidden in the smallest building blocks of existence. Now it is time to bring it all together. Quantum mechanics is more than science. It is a new way of seeing reality. It tells us that the universe is not fixed, but fluid. It is not solid, but shimmering with possibility. Every particle, every atom, every photon is part of a grand dance of probability. And we are not just observers, we are participants in this cosmic story. Think about what this means. The chair you sit on, the air you breathe, the stars above, all of it is built from particles that follow quantum rules. The certainty you feel in everyday life is only the surface. Beneath it lies a hidden code, a deeper truth, a universe alive with mystery. Quantum mechanics shows us that reality is not a machine, but a living system, responsive and creative. It also shows us hope. The same strange rules that make particles behave unpredictably also give us power. They allow us to build lasers, computers, and quantum technologies that can change the world. They open doors to new medicine, new energy, and new ways of understanding the universe. Quantum mechanics is not just about mystery, it is about opportunity. But beyond science and technology, quantum mechanics touches something deeper. It reminds us of ancient stories, of divine mysteries, of the idea that creation itself is alive and responsive. It shows us that the universe is not cold and empty, but connected, vibrant, and full of meaning. It whispers that we are part of something greater, something epic. So, as we close this journey, remember, reality is not fixed. It is waiting. It is alive with possibility. Every time we look, every time we measure, every time we wonder, the universe responds. We are explorers in a quantum ocean, and the adventure has only just begun. We've reached the end of our journey through the quantum world. Along the way, we've seen particles act like waves, cats live and die at the same time, and reality itself bend when observed. We've explored paradoxes that defy logic, technologies that power our modern lives, and even mythic echoes that remind us of humanity's oldest stories. Quantum mechanics is more than equations, it is a new lens for reality. It shows us that the universe is not fixed, but fluid. It is not solid, but shimmering with possibility. Every particle is part of a grand dance of probability, and every observation is a choice that shapes existence. This science is not just about mystery, it is about power. It gives us lasers, computers, and quantum technologies that will transform the future. It whispers that the universe is alive, connected, and full of meaning. It tells us that we are not just observers, we are participants in the unfolding story of creation. So here is the epic truth: reality is not a machine. It is a living system, responsive to interaction, alive with possibility. Every time we look, measure, or wonder, the universe responds. We are explorers in a quantum ocean, and the adventure has only just begun. You've just glimpsed the hidden code of reality, the quantum world where possibility rules and the impossible becomes possible. But this journey doesn't end here. If you want to keep exploring the mysteries of science, faith, and the cosmos, join me. Hit that subscribe button, share this video with someone who loves wonder, and let's unlock the universe together. Because the next frontier is stranger, brighter, and more epic than you can imagine, and you don't want to miss it.